Okay, for question 6, it says a true statement is given. If two given shapes are circles, then the shapes are similar. Select the boxes to identify what could be the converse, inverse, and contrapositive of the given statement. So what we need to remember about these are converse means I switch the hypothesis and conclusion. Inverse means I negate both the hypothesis and the conclusion. And contrapositive means I do both things. I switch and I negate. So we're going to pick one for each of these items. Okay, if two given shapes are circles, then the shapes are similar. So the first one says if two given shapes are not similar, then the shapes are not circles. So I see this word not in both of these, and I notice that they're switched around. So both things happen. So that would be our contrapositive. If two given shapes are similar, then the shapes are circles. So all that happened was I switched the hypothesis and conclusion. So switching is converse. And then if two given shapes are not circles, then the shapes are not similar. So now I see the statements are in the same order, but the words not are added in there. So that means all I did was negate. So inverse. Number 7, the question has two parts. It says the vertices of two triangles are given, and it says the coordinates of the vertices of the first triangle, coordinates of the vertices are the second triangle. We do not want to try to do a question like this without drawing a picture. So that is going to be our first step. We're going to draw a picture. So we can see here, these are our two triangles that are given. Okay, I put my triangles on the coordinate plane. We have Q here, R, and S. And then the coordinates of the second triangle are T here, U here, and V here. Which statement describes the relationship between the first and second triangles? I think the easiest thing to pick out about these triangles are that there is a right angle here and there is a right angle here. So if I'm trying to match up the angles, I know that Q and V are both my right angles, so they have to be in the same position. So as I go through my choices, I'm looking for Q and V to be in the same spot. Here, Q is first, V is last, so A is wrong. Here, Q is first, V is first, so that's good. Okay, Q is here, V is last, that's wrong. And then if I go to my next choice, Q and V first and second, so that's wrong. So the reason I didn't automatically pick B is because I wanted to check to make sure there weren't two choices that had Q and V in the right spot, and I had to test a different angle too. But B would be correct. It's the only one that has Q and V matching correctly. Okay. Part B says select the expressions to create a transformation that proves the statement in part A. Okay, so I want to prove that these triangles are congruent to each other. So when I prove that triangles are congruent to each other, congruency transformations are going to be things that keep them the same shape. So things that keep, transformations that keep them the same shape with that exactly the same size are going to be if I translate, if I reflect, or if I rotate. If I see a dilation, they are not going to be congruent to each other. So I definitely don't want to pick anything that has a dilation, and a dilation would be shown by multiplication. So I'm going to automatically get rid of this one and this one. And then I didn't even realize up here, these two didn't have congruency symbols. They had similarity symbols. So that might have been a clue too, to show, because I could tell that these were the same size. Okay. All right, going back to this. So I know it's not a dilation, so I got rid of those. And now I want to look at my picture and see what's happening. I see this means that I would reflect it, but this means I would reflect it over the y-axis. This means I would translate it to the right 2. This means to the left 2. This means reflect over the x-axis. This means go up 8. This means go down 8. So if I look at my picture and see what's happening, this first triangle up here is getting flipped over the x-axis and it's getting moved to the right 2 spots. So I know it's getting moved right 2, so I definitely want to pick this one. Oops. Okay, because it's moving right 2. And then it's flipping over the x-axis, which means I'm changing my y values. Okay, these y values along here are going to stay at 0. They didn't change, but these y values did change. They flipped. So flipping my y values is going to be choice B here. Okay. All right, next we've got number 8. Number 8, we have a circle. It says an inscribed angle and a central angle are shown in circle C. This is my central angle. Remember, central has a vertex on the center. This is my inscribed angle. My inscribed angle has a vertex on the circle. Create an equation to show the relationship between x and y. So I want to think about my relationship to the arc. Okay, this is my arc that gets intersected. A central angle is equal to the arc. Okay. An inscribed angle is equal to half the arc. So how would these angles relate to each other, right? So another way to write this part would be 2 times the angle is equal to the arc. So if I wanted to relate these two, since x is equal to the arc and 2 times y is equal to the arc, then I could say x is equal to 2y. This angle is twice as big as this angle. So this is a question where you'd have to type the equation in. So you could either type in x equals 2y or 2y equals x. They mean the same thing, so either answer would be accepted. Okay. You could even switch it up and you could say that y is half of x. So if you wanted to say y equals half of x, that would also work. The great thing about the EOC is it would take any of those forms for the answers because they all mean the same thing. Okay, number 9. Number 9 says figure A is drawn in a coordinate plane. Transformations are performed on figure A to create figure B. Select the boxes to identify whether each transformation performed of figure A results in a congruent or non-congruent figure B. So congruent, remember, means same shape and same size. And we talked about in the previous question, things that are going to be congruent are going to be translations, rotations, and reflections. Those are things that keep the shape the same exact size. Something that would not keep it congruent would be a dilation. Dilation would be the same shape, but not the same size. So here we have a reflection happening. So if this is a reflection, actually, that's more than a reflection. That's a rotation. Okay, I'm not multiplying. I'm just switching spots and changing signs. So this is going to be congruent. Here I'm multiplying by 1/2. If I'm multiplying, I'm changing the size, so that's not congruent. Reflection is congruent, and a rotation is also congruent. Okay, and then number 10. Number 10, we have a midpoint question. Okay, it says a line segment has an endpoint at 1, 1 and a midpoint at 1, -3. What are the coordinates of the other endpoint? Again, sometimes it helps to draw a picture. You have all of this graph paper to use, so it's probably helpful to draw your picture. Okay, we have 1, 1, which is right here, and 1, -3. So 1, 2, 3 here. -3, -2, 1, 1. This is our segment. This is an end, this is a midpoint, and we're trying to figure out what are the coordinates of the other endpoint. So if I'm traveling from this end to the middle, I'd have to travel the same distance to the other endpoint. -4, -5, -6, -7, -8. So I want to see how far did I travel here. I traveled 1, 2, 3, 4 spaces. So I want to travel 4 spaces in the other direction. 1, 2, 3, 4. So this would be where my other endpoint is. So the coordinates of that endpoint are going to be 1, -7. So D.